College. Welcome to my lesson on Introduction to Fractions, Decimals, and Percents. In this lesson, I'm hoping that you've had some previous practice to fractions and decimals because we're going to show you how that relates to percents. And really, in order to calculate percents and percent applications, you're going to have to convert the percent back to a decimal and a fraction. And so all I want to do today in this lesson is just take a look at that conversion piece, converting percents back to decimals and fractions, and then vice versa. Okay, I want to start with an example that many of you can relate to. Let's say that you had been in school and you had taken a quiz. It was an 8-point quiz and you had scored 7 out of 8 correct in the quiz. What I've done here is I've written a ratio of the part that you had correct to the total number possible. Okay, this is something we're going to come back to later. But you're looking at that 7/8 and you're thinking, hey, I did pretty well, but I'd kind of like to know how I did in terms of percents. And I want to talk about how that happens. How did your teacher or the computer convert this fraction, the part over total fraction, to a percent? What I want you to be able to do is look at every fraction as a possible division problem, where you take the top number, goes under the house, the top number goes under the house, divide by the bottom number. So in this case, 7 is my top number, my numerator, and I'm going to divide that by 8. Okay, the deal here is that 8's bigger than 7. It does not go into 7, not even one time. So it kind of makes sense that we're going to have to place a decimals, and our 0, and go ahead and carry out a decimal division problem. Okay, 8 goes into 70 8 times. 8 times 8 is 64. We're going to have to borrow, find that we have a remainder of 6. As long as I have a decimal placed here, I can keep adding zeros in this decimal division. So I can bring down the 0. 8 goes into 60 7 times, because 7 times 8 is 56. Again, I'm going to have to borrow and find out that I have 4 remaining. I can add another 0 and bring that down. 8 goes into 40 5 times. Okay, I could say this number is 875 thousandths. Okay, so this would be the decimal notation that is equal to that fraction notation. Now this really isn't part of my lesson, but it's a chance for me to review this with you. That the 8 is in the tenths place, the 7 is in the hundredths place, the 5 is in the thousandths place. And in fact, if I wanted to write that back as a fraction, I would write 875 over 1,000. And if I wanted to, I could divide both numerator and denominator by 5 over and over and over again, and I would eventually end up with 7/8 again. Again, that wasn't part of my lesson, but I wanted to prove to you that this decimal notation is equal to this 7/8 fraction notation. Okay, so now I could look at this and I could say that you have mastered, actually I could go back to this fraction, I could say that you'd mastered 7/8 of the concepts covered on that quiz. And for most of us, that doesn't connect. So once I've converted it into a decimal, I could then say that you've mastered 875 thousandths of the concepts covered on that quiz. But again, that generally doesn't have a whole lot of meaning for most of us. Most of us want to know, on a scale out of 100 points, how did I do? And that's really what percent is. So I could take this part of a whole and I could multiply by 100, which means I'm moving that decimal 2 places to the right, and write that as 87.5%. And those three are equal to each other, the percent, the decimal, and the fraction notation for that ratio proportion. I'm going to go ahead and do another example. Let's say that you had scored, it was a 6-point quiz. And again, we're going to do part over total here. And let's say that you scored 5 out of 6. Okay, again, we want to go ahead and carry out a division, top number divided by bottom number. So the 5 goes under the house, the 6 comes outside. 6 is bigger than 5. It doesn't go in there, not even one time, so we're going to have to place our decimal and our zeros and carry out a decimal division problem. 6 goes into 50 8 times. 8 times 6 is 48. We're going to find that we have to borrow and bring down a 2. We'll have our 0, bring down. 6 goes into 20 3 times. 3 times 6 is 18. Again, we're going to find that we have 2 left over, and we could add another 0, bring it down, and we're going to find that, geez, we're going to have this 3 repeating over and over and over again. So when we go to move our decimal 2 places to the right, we have some options here on how we present this percent. I could round this to the whole number, which means I'm looking to the right. That's less than 5, so I'm going to come back and leave this as 83%, rounding down. If I had my decimal here, I could know that the next digit's going to be 3. I could round it to the tenths place. Means I'm looking to the right. I could come back here and identify this as 83.3%. Or I could look at this and say, just take a look at my remainder of 2 and place 2 over 6, and that could reduce to 1/3. And so I could identify this as 83 1/3%. This last one is actually most accurate because the other two required us to round off to some decimal place. But all three of those would be acceptable ways to communicate each of these fraction or decimal notations for that ratio. Another example that I can do is, let's say that you had, or I had a deck of cards, and I threw out the deck of cards and asked you to pull a card. And I asked you, what were your chances of pulling a heart? What I can do is I can write my ratio again of part to total. The total number of suits in a deck there's 4 suits, and only one of those suits is hearts. So there's 4 suits, and one of those is hearts. Okay, we want to look at what's the chance of pulling a heart. I could look at that ratio and just say I have a 1 in 4 chance, or a 1/4 chance of pulling a heart. I can go ahead and carry out my division. I'm going to take 1 divided by 4. I'm going to have to place my decimal. Move my decimal up. 4 goes into 10 2 times, because 2 times 4 is 8. Find that we have 2 left over. I add a 0, bring it down. 4 goes into 25 times. So I could say I have a 25/100th chance of pulling out a heart, which is also equal to my 1/4. Or I could move that decimal 2 places to the right, make that 25%. I could say that you have a 25% chance of pulling a heart. I just wanted to point out here that probability is basically that part to total ratio, and it can be communicated as a fraction, a decimal, or a percent, and very often it's communicated using different notation. A 1:4 ratio is another way that could be communicated. But again, just an opportunity to kind of wrap those concepts together. Okay, let's say we are going the other way around. Let's say we have a percent, and really this is the case that I'm trying to get you ready for, is that when you have percent application problems, you have to take a percent, and you're going to have to convert it to either a fraction and use fraction skills, multiplication, addition, or whatever it might be, or decimal skills. So I want to talk about both of those things. Let's say a good example is we live in a state that has 6% sales tax. Okay, I could write that as a fraction just looking at what is the meaning of percent. Percent means per 100. Okay, so I could rewrite that as a fraction by saying 6 over 100. And if I wanted to, both of those are even. I could divide both numerator and denominator by 2, which would give me 3/50ths. This would be an equal fraction. These are equivalent ratios or equivalent fractions. Dividing both numerator and denominator by the same number, a common factor, is how we simplify fractions. Again, that would be a skill that you would practice with your fractions. So just connecting that the percent means per 100 and taking your number and writing it over 100 and then reducing is all you need to do to take your percent and convert it into a fraction. Okay. The other thing that I wanted to point out is, let's say I'm going to take that 6% again. And if you remember back when we were dealing with percents, or going from a decimal to a percent, we went 2 places to the right to get from a decimal to a percent. It kind of makes sense that when I'm going from a percent to a decimal, that I'm going to go 2 places to the left. So there's an implied decimal here. This is a whole number 6. So there's an implied decimal here, so I'm going to have to move 2 places back to the left. Now, because there is no digit there, I'm going to have to remember to use 0 as a placeholder so that my 6 ends in the hundredths position. And I'm going to say this number as 6/100ths, which is the exact same verbiage as I use when I say 6/100ths in fraction form. So these are all equal ways to communicate the same ratio there. Okay. If I had something like, 32%, again, I could write that as 32 over 100, which they're both divisible by 4. 32 divided by 4 is going to be 8. 100 divided by 4 is going to be 25, and I could leave it at that. What I want to point out here is that when I'm taking this decimal and moving it 2 places back to the left, I go 2 paces back to the left, I don't need to insert a 0 here because I already have 2 digits. Okay. Sometimes students get confused with which way do I move that decimal, especially if they're dealing with very unique types of percents. One way that you can remember that is there's a play on words, that if you're moving it to a percent, in other words, you have a decimal and you're going to a percent, there's a play on words here. You know that you're going to go 2 places. To a percent, you're going to go 2 places to the right. Okay, and if you're moving to a decimal, again, the play on words, you're going to go 2 places to the left because there is an L in decimal. Now, of course, that isn't why. The fact that there's an R in percent and an L in decimal just makes it helpful for us to remember. That isn't exactly why, but it helps us remember. Okay, that is all that I wanted to do in terms of communicating how we convert between fractions, decimals, and percents. At this point, if you could practice in any of your texts or materials, whatever you might have, anything that goes over converting fractions, decimals, and percents. And then after this, we would move on to actually some percent applications where you're finding the different components of a percent problem. Thank you for joining me on this lesson.